Hi everybody, this is Alex Gorbunov from Visuals, again with another video tutorial for you. This time I want to show you how to model a spiraled hose. This type of object you can probably see every day. It's widely used in the plumbing industry. It comes in a variety of profiles, lengths, and materials. And like with any other object in 3D Studio Max, it can be modeled with the multiple different techniques. I just want to show you my favorite technique that I use almost every day when I need to have that type of object as a geometry. So let me go ahead and show it to you. Open the first file from the project folder, and what you will see in that file is the 3D model of the floor mount faucet that is obviously missing the spiraled hose, and we are going to model that spiraled hose in this tutorial. It will start here at the top, then we'll go down and around the spout of the faucet, and we'll end up entering the left side of this hand shower. And first, in order to make that spiraled hose, we will have to create a spline that will serve as a path along which we're going to conform the geometry of the hose later. So let's go ahead and start making that spline. So on a command panel, go to Shapes menu, click Line button, so you can start creating a line. Start here at the top and try to use as few vertices as possible. Basically, you can just follow my example. So don't worry if your shape is not coming out, nice. The goal here is just to create some rough representation, just a basic outline of what the path gonna look like. And obviously, you can see even my shape is all, look funny. But that's fine, because right away after we created the spline, we're gonna go to Modify panel, then go to Vertex of Object mode of this editable spline object, and adjust each of these vertices manually. And before we do that, also go to Interpolation Rollout and enable this adaptive checkbox. This will make your spline look a little bit smoother, and it will just make the whole process of adjustment of each of these vertices easier. So also select all vertices. You can just push Ctrl A on the keyboard while in the vertex of object mode. Click over any of the vertices and switch them to the Bezier type, so that we can be sure that each of these vertices have the control handles. So now you can adjust each of them individually, reposition each of these vertices and adjust their control handles so that you sculpt this spline into the look that you want. Use your best guess of how would that spline should look in order to make the hose to look properly once attached to this faucet. And when you're doing so, sculpting the spline, one other thing to remember, make sure you take this starting and the ending point vertices of the spline and push them inside those connectors a little bit, like you see I'm doing right now. Yes, like that. So that looks good. Let's also go to perspective view and position it a little bit better. So that looks about right. And one thing you can notice right away is that this spline is intersecting this joint where the water is connected to the valve. So this is not correct, and we need to make the spline go around it. So in order to do that, we would really need to have extra vertex right here, but we already created our spline and there's no vertex in there, which is not a problem. We're going to insert it right there. So if you are still in the vertex of object mode, just stay there. If you exit it like me, go back there by clicking this button over here. Then scroll down until you find this refine button, click it, and after that you can choose any place on your editable spline to insert vertex. Simply click left mouse button, you'll insert vertex in that place without changing the shape of the spline. So now we can adjust the flow of the spline however we want. So that looks much better, and of course that will involve the need to correct all other vertices a little bit to make everything look nicer. So it might take you, a minute or so. So just do your best trying to make it nicely, flow around that joint. And of course, you will also have to adjust this vertex at the bottom. You might need to go to side view to do a better job, and also play with the Bezier corners of that vertex. So okay, that looked like something now, and that would be a good path along which we will conform our geometry later. So right now, if you feel confident about your scene, you can continue with what you have right now, or if you want to be consistent with what I have, you can open a second file from the project folder. Now when we've got the path along which we're going to conform the geometry of the hose, it's time to actually go ahead and start making that geometry. So zoom in closer to the outlet element of this faucet, and while having it on the screen, it will help us to just better judge the size of the profile that we will create next. So on the command panel, go to the shapes again and create another line. Make it something similar to you see I'm making. In reality, it can be any other profile. You can experiment with it after this tutorial. Right now, I'm just trying to keep it simple and generic for the sake of demonstration of the general idea how you can make spiraled hoses. So when you've got the profile similar to this one, another important step is to make sure that your first and the last vertices of the spline are aligned along x-axis. Now, the reason why is because later we will turn it in geometry and we will weld some vertices, and if they would not be aligned, we'll have some problems. So on the modify panel, go to vertex of object mode of this editable spline, select end vertex, make sure you enable snaps toggle button. So grab end vertex by the x-axis, move it around until it snaps to the X position of the first vertex of the spline. So now we've aligned them. Now we can also, while we're still in the vertex of object mode, we can also smooth out the corner vertices. So go ahead and select them. On the modify panel, scroll down, find and enable fillet tool that will enter you into fillet creation mode. So while in the fillet creation mode, you can position mouse cursor over any vertices and click left mouse button and drag your mouse up and down to smooth out those corners. And you can click right mouse button to exit from fillet creation mode. So we've got our profile. Now let's also isolate it so we can see nothing else on our screen except that profile. So click right mouse button and from the quad menu choose isolate selection. So this is our profile. Now it's time to turn it into geometry and do a couple other things. So let's go step by step and turn it into geometry first. So go ahead and apply extrude modifier to extrude it. And you might see it disappear immediately. That's because by default, extrude modifier has a mount parameter set to 0. So don't worry about it, just give it a couple clicks to extrude it. And here's what our object looks like once turned into geometry. You can see that it's a little bit on the high poly side. So this would be a time to make your first call for this project and decide what level of detail you want this object to be. Do you want to keep it on a low poly side, or do you want to keep it on a high poly side? It depends on multiple factors. It depends on your personal preferences. It depends on the power of the computer that you have, how much memory it has. So just choose the level of detail that you're comfortable with. Let me just show you how you can adjust it. So go to line object and make sure you click this show end result button on the stack of modifiers so that you can always see what this object look like with all the modifiers applied to it while still editing it. So then find interpolation rollout. And remember, we enabled this adaptive checkbox in the beginning of this tutorial when we made the path for the hose. And while until you restart your 3ds Max, it will remember this checkbox with every next spline that you create. So if it's still enabled, go ahead and disable it. And you will see that now level of details of this object is dictated by this steps parameter, and you obviously can go with a higher level of detail by increasing number of steps, or you can go with a lower level of detail with decreasing number of steps. So choose the number that you're comfortable with. I prefer to keep it somewhere in between low and high poly, something like this. So me personally, I'm choosing 2 steps for this particular case. So okay, so this is what our profile would look like once turned into geometry. Now when you use Extrude modifier with open splines, keep one thing in mind: your normals might be flipped. So go ahead and click right mouse button over this object, go to object properties, make sure you enable backface call checkbox, hit OK, and that will give you a better idea how normals of this object look. So obviously they are inside out and we need to fix it. There are few ways to fix it. Right now, just let's use the fastest way and go ahead and apply normal modifier at the top of modifiers list, and I will simply flip the normals with the flip normals checkbox enabled. So okay, so looks like our geometry will be just fine. Now it's time to extrude it a little bit more, and go to Extrude modifier, and we will need to increase extrusion amount for this modifier. Now with the current view that I have, if I go with a positive number, I will extrude this object toward the camera, but me personally, I feel more comfortable if I extrude it away from the camera, so I'm gonna go with the negative value. And in the most of modifiers in 3ds Max, it's very intuitive. You go with the positive number, you apply modification in one direction. If you go with the negative number, you apply it in another direction. So, and here you go, if I apply negative value for amount parameter, I just extrude in another direction. So in this case, it's away from the camera. So let's make it something like this, not too long, not too short. So now we need to subdivide this object along the length, because we are going to bend this object, and it's not going to bend nice if it doesn't have enough subdivision here. So in order to do that, we can increase segments parameter of Extrude modifier, and again, this would be your second call regarding level of detail. And if you go with a higher number for segments parameter, of course it will be on a high poly side. If you go with low numbers, you'll keep it low poly. So choose the number that you're comfortable with, but keep in mind that with Extrude modifier for the segments parameter, you can't go higher than 100. 100 is a limit, so you'll have to choose number between 1 and 100. In our case, I think 65 or 67, I think 65 would be my choice. So I'm gonna keep it 65 for this demonstration. Now before we start bending this object, let's go ahead and apply Skew modifier, and you'll see why in a couple seconds. So on a list of modifiers, find and apply Skew modifier, and make sure it's applied above Extrude modifier. So if somehow your modifier appears to be at the top of list, simply select it and drag it in the place where you want it to be. So like I mentioned, it should be above Extrude modifier. So now Skew modifier, let me demonstrate. Basically skews all geometry along any of the chosen skew axes. So, and this is not always very intuitive modifier, so you might have to play with the numbers a little bit to get the better idea of in which direction you're skewing it. So I know that in this case the direction would be 90 degrees, and now I'm skewing it along z-axis. Now the reason why we want to skew this object before we bend it is that if we would have bent it without skewing first, each individual turn of this profile would be at the same level, and that will make it, doesn't look correct. We want each individual turn go one level up, and the Skew modifier will help us to achieve that effect. So You will see it better once apply bend modifier. So go ahead and choose bend modifier from the list of modifiers, apply it above skew modifier, and just like with extrude modifier, if you go with the positive number, it will bend object in one direction. If you go with negative number, it will bend in another direction. In our case, we're bending it with the negative numbers for angle parameter. And if I apply minus 360, it will make one complete turn. But that's not enough, so we need to keep bending it. So let's make 2 turns, which would be minus 720 degrees. So we've got 2 turns. So we need to keep bending it more. And in order to avoid all the calculation inside your mind, you can just type R negative 360, and it's gonna take number after letter R, and if it's a positive number, it will be added to whatever value is already in that modifier. If it's a negative number, it will be subtracted. So in our case, it's R negative 360, means this number will be subtracted with that value. So hit OK to apply. Looks like we can bend it even more. So go R negative 360 to bend it more. And maybe one more turn will do it. So go R negative 360. So there you go, and we've got something that starts looking like a piece of the spiraled hose. Now you can see that these individual turns are too tightly packed, so we need to, spread them a little bit more. So go to the skew modifier and increase this amount parameter to adjust how tightly individual turns are packed. And this is going to be another important step. So make sure you play with this amount parameter. You pick this parameter so that the gap in between individual turns is almost close. So just use your eye judgment and just make them almost close. Now the reason why we want to do it is that later we will weld all these vertices along the edges over there, and by having them as close as possible to each other just will help weld tool to find those vertices. Okay, now another important step, just something you keep in mind, that remember that for extrude modifier we had to choose number of segments. Not all, and let's say if we have chosen number 64, you can see how each of these vertical edges that divide this object along length, they are not creating one consistent line. Now make sure you choose number of segments for extrude modifier so that the final object, once it turn into the piece of the spiraled hose, each of these vertical edges create some sort of continuous line. You can see it right here. So if I need to increase level of detail, and let's say I go with a higher number, keep increasing it, and you'll see after a few steps all of those lines will be parallel again. So okay, let's say in this particular case we want to keep it 70. Okay, that looks like a nice little piece of a spiraled hose. Now would be a good time to also apply a mapping to this object, because in future there is a chance that we will decide to apply, let's say, brushed nickel or brushed bronze material to our spiraled hose, and by having proper mapping on this object, it will help us to apply brush strokes texture. So let's go ahead and take care of the mapping. Now in order to see how mapping on this object look right now, let's open material editor, choose any empty slot on the material editor, and apply checker map to the diffuse slot. Okay, and right away when I do it that way, I increase the tiling to 10 and apply it to my object and make this texture to be visible. So you can see, even though it's supposed to be visible, it's invisible. That's because our object don't have any UV mapping coordinates. Now the reason why is because when you extrude your splines, they don't have mapping coordinates by default unless you enable this generate mapping coordinates parameter on Extrude modifier. So go ahead and enable it if it's not enabled. You can see now our object has mapping, and even though this mapping is applied in the right direction, it's stretched along one of the it's stretched in one direction. Now that's because we can fix it by increasing the tiling number for the V axis, and eventually, let's say if I choose 150 or 180, it starts looking about right. But we don't want to adjust every texture every time we apply it to this object, so we will do it differently. So keep tiling square 10 by 10. On top of your modifiers list, apply UVW X4 modifier, and inside that modifier you can apply texture stretching by these UVW tile parameters. So in this case we need to increase V tile number, so keep increasing it until you see the texture stretching problem disappear. So I think something like that looks about right. So when you pick the right number that work best, always round it up to the closest normalized number. In this case that would be, let's say, 33. So this is important, so always keep the full number. Don't go 33.1 or 33.5. Go 33, 34, 25, 27. So now every time we apply the texture to our object, it will be properly applied and properly stretched. Okay, now when we've taken care of the mapping, we can continue working with the entire host geometry. So let me disable this map in the viewport, go back to the front view, and I can exit from isolation mode right now. So for the next step, I want to adjust the scale of this object in relation to this connector into which it will be fitted. So go ahead and rotate this object 90 degrees. You can just select this object, click right mouse button over select and rotate tool, and in the rotate transform type in, just type the minus 90 to rotate it 90 degrees clockwise. So position it against that place where it will be fitted, and use just the select and scale tool to scale it up and down. Now when we created our profile, depending on its size, this object might be larger than it's supposed to be, but it also might be smaller than it's supposed to be. So you not necessarily have to scale it down, you might have to scale it up. So don't worry about it. To demonstrate it to you, I'm gonna open pre-saved file. In the pre-saved file I have a similar state of this project when I have created the piece of the spiraled hose. Same structure, I got my extruded editable spline, then it was skewed, bent, normals were fixed, and the mapping was fixed. And let me rotate this object 90 degrees again, but in this case you can see it turned out to be smaller than it's supposed to be, so I had to scale it up. So I'm not sure which case you will have, but you'll see either you have to scale it up or down. So by visually looking at these objects, superimpose, just get the scale right, relatively right, okay, and bring this object back to vertical position again. Now another important step before we do anything else is to tell computer that this scale is 100%, because right now you can see if I go to select and scale tool and click right mouse button over to bring scale transform type in dialog, you can see the current scale of this object is 252. With the path deform modifier, which we will use to conform our hose geometry to the path, the way the modifier works, it will reset it back to 100, so your object will jump back to being small. So we need to tell computer that this is 100%, and this is the easy fix. So go ahead and go to hierarchy panel, and scroll down, and in reset group click scale button. That will reset the scale of this object. And now you can see if I bring transform type in dialog, it says 100%. So 3ds Max does consider this object to be at the 100% scale. Now another important thing we can fix while being in the hierarchy panel is to fix the pivot point of this object, because right now you can see the pivot point of this object is at the beginning of that extruded spline, and it needs to be at the center of this geometry. So in order to fix that, on the hierarchy panel at the very top of it, hit apply pivot point, affect pivot only button. That will enter you into pivot point editing mode, and then hit center to object button. It will simply center it to your object. So when you finish that, you can exit from hierarchy panel, and here you go. This is our pivot point properly centered. If I go to top view, you can see it better. Okay, so now back in the front view, and I can collapse this object into editable poly. So go ahead and click right mouse button over it, convert it into editable poly. And now what we need to do is to take this element and copy it multiple times along y-axis to create one long continuous hose. So, but the problem right now is that we don't know how many times do we need to copy it, so that this little piece of geometry, when copied multiple times, make up the spiral hose of the length that will be enough for us. So that's not a problem, because we can find out the length of our path. So go ahead and select that path, spline. While having it selected on the utility panel, go ahead and click measure button. That will bring up measuring rollout, and in that rollout, in the shapes group, you can see the length of selected spline in system units. So our system units is set to inches, so it's 87 and 2/8 of an inch. So all we need to do is just to create a hose of this length, and once it conform over spline, it will be exact length of the hose that we need. So now let me create some reference object of this length, and I don't need to go far. I go to standard primitives panel and create simple box, and then make it a little bit longer than the length of that path. Remember, the length was 87 inches. Let me make this box 89 inches tall. So that would be my visual reference. So I'm gonna grab this piece of a hose, position it at the bottom of this box, zoom in closer to it. Now here's what you need to do next. Make sure your snaps toggle button is active, and lock y-axis. Just position your mouse over it, click it once, so you lock the motion of this object to y-axis. Grab this object by one of the end vertices right here. So let me zoom in. We're gonna grab it by this vertex over here. So while holding shift on the keyboard, grab this object by that vertex and snap it to the corresponding vertex at the top, so that both copies smoothly flow one into another. So when you release left mouse button, 3ds Max is going to ask you how do you want to copy it. You want to make a copy instance or reference, so make sure you choose copy, and here you can choose how many copies you want to make. So go with something that you can be sure be enough. So let's say 60. You hit OK, you can see that we've made this many copies of our hose, and it's actually created hose a little bit longer than we need. So go ahead and delete what you don't need. Yeah, don't worry if it's just a bit longer. We will delete extra geometry later when we're done. So now you can delete our box. We no longer need a reference. Now we need to attach each of these individual objects, because you can see, even though it looks like one continuous hose, it's still made up by a bunch of individual tiny little objects. So now we need to attach all of them together. So you can select any of these objects, go to modify panel and hit attach button, and attach each of them manually by clicking them in the viewport, but that's gonna take you a little bit of time. And here's the faster way how you can do it, how I would recommend you to do it. So go ahead and select each of these objects with the window selection and isolate them so you can see nothing else on your screen except those objects. Now select one of them, and instead of clicking attach button, click attach list button. That will bring up the attach list dialog window, which show you all the objects in your scene, and make sure that this button here, display hidden object, is not enabled. So all you see here in this list is only the objects that are currently in your viewport. So hit Ctrl A to select everything, then hit attach, and they all will be attached together. So now we have one editable poly object that represent our host. And let me exit from isolation mode. So technically you can stop here and start conforming this host to the path, and that will work, but I would recommend to weld all vertices along open edges, because right now you can see if I go to elements of object mode, even though it's one editable poly object, it's still made up by a bunch of individual elements that are not welded together. So let's go ahead and weld them. So in order to do that faster, go to borders of object mode, and again hit Ctrl A, so it will select all open edges of this object. Now while holding Ctrl on your keyboard, go to vertex of object mode, and you will enter into vertex of object mode, and you will have all the vertices that belong to the open edges already selected for you. So now zoom in closer to the place like this on the spiraled host, and let's go ahead and weld those vertices. So find weld settings button next to weld button, go ahead and click it, and that will give you weld threshold dialog. Now immediately when you've done that, you'll see some change, some vertices that you don't need are welded. So go ahead and click right mouse button over any of the spinners of the weld threshold group. It's not gonna weld anything, and you can see that this number of vertices before and after is not changed, and that's indicator that is nothing is welded. Hold Alt on the keyboard and click mouse button over any of these arrows, and start dragging your mouse to the right to start increasing weld threshold parameters slowly. So keep increasing them, and let me do it again, until you see the vertices are snapped to each other, so they welded. So as soon as you see the desired result, stop dragging your mouse, because if you keep dragging it, you will keep increasing weld threshold parameter, and eventually you're gonna start welding vertices that are not meant to be welded, and you can see that on your screen right now. So again, start with 0, increase it very slowly until only vertices that you need to weld are welded. And don't worry if weld threshold is still showing 0. The reason why is because the value that we apply is still below the smallest unit of your scene units, and in our case it's 1/8 of an inch, and that's why you still see it as a 0. So, but indicator that the vertices have welded would be of course the visual information that you see on your screen, and these numbers right here that show you number of vertices before and after. So obviously vertices that we need are welded, so hit OK to confirm, and there we go, we've welded everything. And even if I bring back the map to display it in the viewport, you can see we've got one continuous spiral hose object that is a one piece of geometry. If I go to element and click anywhere on this hose, everything gets selected, so that's a confirmation that it's one continuous chunk of geometry. Texture mapping is correct, everything is correct, so it's finally time to conform this object to the path. So go ahead and apply path deform modifier to this object, and let me close material editor. So on the list of modifiers, find and apply path deform modifier. But keep in mind though, there are two modifiers like that. One is here in the Weld space modifiers group. It's called path deform WSM. Another one in object space modifiers, and it's called path deform. So make sure you apply this one from the Weld space modifiers. So choose it, and right away click pick path button and pick your path, and you will see that your object move. So, and it moved in a place where it's not supposed to be. So in order to move it to your path, click move to path button. It will jump to the start of the spline. And now you can adjust the placement of this by changing these path deform axes. So let's see which one works, X or Y. Y, well, looks like it works. So even though it looks about right, there's still a problem with it. Let me zoom in to show you what exactly is the problem. You can see that the hose geometry now got stretched in some place, got squished in some other place, non-uniform along entire length of this path, which is not good. And that's because our path is represented by the spline that has Bezier vertices, and each of them have a Bezier control handles. And actually that's what make this object to be squished and stretched in some places. We will fix that and I'll show you how. But before we do that, since we have the hose applied along the path shape, and we can see its diameter now, let's fine adjust the placement of our spline. So go ahead and choose our spline object, go to vertex subobject mode, and by choosing the start and end vertices, let's fit it better into that fitting. So just drag it around in the viewport until you can see it's properly entering that connector right here. And you might want to, play with the placement of the vertex a little bit. Okay, don't worry if some extra geometry sticking out beyond this connector. We will, like I mentioned before, we created the hose a little bit longer than it's supposed to be because we will trim extra geometry that we don't need at the end of this tutorial. Okay, now let's do the same on the other side of the path. Let me zoom in and adjust this vertex a little bit. Okay, so that looks better. And let me also check this another spot here where the spiral hose go around this joint. Let me select this vertex and move it a little bit closer so it naturally touches that. Okay, so it looks like the flow of the spiral hose around the path is okay. Now let's go ahead and get rid of that squishing and stretching problem. Now let me temporarily hide my hose geometry, so select it and from the quad menu choose hide. Let's also select our spline, and while you have it selected, click right mouse button over the spline, go to object properties and enable vertex ticks checkbox. Hit OK, and that will make us to always see the vertices of this object regardless of what we have selected in the viewport. So now, again, while having this object selected, let's apply Normalize spline modifier. And right away when you apply it, you can see that your shape doesn't look right now. Now, let me explain to you what happens. Normalize spline modifier takes your spline and rebuild it with individual segments of the length that you set right here. So right now, segment length set to 20. So this spline is rebuilt with each of these segments being of this length. Now, if you reduce that number, you can see that splines start looking better and better and better and better. But reality is that none of these numbers will really make it perfect except number 1. So you can reset it to 1 right away, and your spline will be made by a bunch of segments of the length of 1 unit. So each of these, so now you can convert this object into editable spline, go to front view, zoom into the beginning of the spline, and go ahead and fix this first vertex. So every time you apply Normalize spline modifier, I recommend you to revisit first in the end vertices of your spline and fine-tune them, because Normalize spline turn all vertices of the spline into the smooth type, and we need to bring back the beginning and end vertices into Bezier type. So go ahead and select the beginning vertex, start vertex, turn it into Bezier type, and bring it back to normal by manually adjusting the control handle. And maybe you will also want to adjust the second vertex just a little bit. Okay, so that looks much better. And check if everything looks okay at the other end. Let me bring it back to Bezier type. Adjust it like this. Okay. Alright, so we fixed the distribution of the segments of the spline. And now if I unhide my spiral hose geometry, you can see that there's no stretching or squishing problem anymore. So everything looks much better. I confirm it here at the bottom. And the only thing left to do here is to trim off the success geometry. So this is how you can do it. First, you need to turn it into editable poly. And keep in mind, when you deform object with path deform modifier, if you try to turn it into editable poly with your normal way, by clicking right mouse button, choosing convert to from the menu and choosing convert to editable poly, you will collapse everything on a stack of modifiers into editable poly except this path deform modifier. So in order to turn that into editable poly, click right mouse button directly over that modifier and choose collapse to, and that will give you some warning message. Don't worry about it, simply hit yes. And now we've got this converted into editable poly. Okay, so let's go to front view, zoom in closer to the place where we want to delete our geometry. And from here, you can go a few ways. You can just select vertices and delete them. But if you do it that way, be careful. If you delete a little bit too much, you might create some gaps into the geometry like you see right here. So I recommend to do it a little bit differently. Go to polygons of object mode, select polygons around the place where you want to trim, scroll down on modify panel and find this group of buttons related to the slice plane. Enable split checkbox and click quick slice button, and that will enter you into the slicing mode where you can designate the beginning and the end of a slice with line. As you hit left mouse button to finalize it, it will slice your geometry, you can see, along that line, and it will also separate the geometry into two elements. So now you can see if I go to element, these are two separate elements. So select the one that you want to delete and delete it. And repeat this on the other side of hose. Select polygons, go back to the quick slice mode, designate the line along which you want to slice it, go to elements of object mode and delete the element that you don't need. So there you go. We can also delete our old path spline because we no longer need it. So, and we've finished our spiraled hose. You can keep it as a separate object, or you want to attach it to the entire faucet geometry. So that's all for this video tutorial. I hope you enjoyed it. If you have a comment or a suggestion, feel free to send us a message using contact form on our website. Don't forget to like our Facebook page, and also don't forget to follow us on Twitter so you can stay updated on latest and greatest news that we have. Again, this was Alex Gorbunov. I will see you next time.